Welcome to Still Science Lab. Tonight, we will explore the quiet, rust-colored shadows of our solar system and delve into a profound mystery that has just echoed across the void of space. We are going to uncover the chilling reality behind how Perseverance just heard a strange sound on Mars, an anomaly that violently disrupts our understanding of the dead, red planet. As you allow the heavy noise of your daily life to fade into the background, let your mind drift away from the comforting gravity of Earth. We are traveling outward, across millions of miles of freezing, empty vacuum, moving past the silent debris of the inner solar system until we reach the desolate, wind-swept surface of an alien world. For centuries, humanity could only look up at the night sky and wonder about that faint, crimson dot wandering through the dark constellations. It was a blank, silent canvas for our wildest imaginations, a distant sphere we painted with desperate stories of ancient canals, dying civilizations, and terrifying, intelligent invaders. But today, the era of pure, unchecked imagination has been entirely replaced by an era of unprecedented, cold, mechanical presence. We have successfully surrounded and invaded Mars with a vast, highly sophisticated fleet of spacecraft and robotic rovers. Orbiters silently circle the planet day and night, using advanced radar and high-resolution cameras to map every single impact crater, every dried, ancient riverbed, and every towering dead volcano. Down on the surface, a lineage of metallic explorers has spent decades crawling slowly across the freezing regolith, grinding ancient rocks, baking soil samples, and analyzing the chemical exhaust of a world that lost its protective magnetic shield and its sprawling oceans billions of years ago. Because of this relentless, robotic armada, we now know more about the intricate geology, the atmospheric composition, and the deep history of Mars than we know about any other planetary body beyond our own Earth. We have mapped its desolate valleys with more precision than we have mapped the crushing depths of our own ocean floors. We sent this incredible fleet of machines to the red planet with highly specific, rigidly defined missions. We built them to be geological detectives, carefully programmed to search for the microscopic remnants of ancient water, to hunt for the fossilized chemical signatures of extinct microbial life, and to meticulously catalogue the mineral diversity of the rock. We approach planetary exploration with strict itineraries and rigid expectations, believing that if we design the perfect instrument, we will find exactly what we are looking for. We naturally assume that Mars is a static, dead museum, a frozen archive of planetary failure waiting patiently in the dark to be catalogued by our machines. But planets are not static. They are vast, complex, and chaotic systems, governed by atmospheric fluid dynamics and deep physical laws that care absolutely nothing for human expectations or our neat, scientific categories. Despite all of our advanced computer modeling, and despite decades of close, unbroken observation from orbit and from the ground, the red planet still possesses the remarkable ability to fundamentally surprise us. It constantly reminds us that the universe is wild, untamed, and entirely indifferent to our carefully constructed boundaries. This profound realization of our own ignorance was recently brought to light by NASA's Perseverance rover. Dropped violently into the ancient, dusty basin of Jezero crater, Perseverance is a towering, miraculous feat of human engineering. It is a nuclear-powered astrobiology laboratory, bristling with heavy lasers, sophisticated mass spectrometers, and intricate robotic arms designed to drill into the ancient bedrock and carefully cache pristine samples for a future return to Earth. It was explicitly built to look down, to scrutinize the dirt, and to uncover the slow, silent history of rocks that have sat undisturbed for billions of years. But while the rover was dutifully executing its programmed routines, staring blindly at the ancient ground, it detected something completely unexpected. It captured a fleeting phenomenon that it was fundamentally not designed to investigate. The anomaly was not a visual one. It was not a strange shadow moving across the shifting dunes, or an inexplicable chemical signature hidden inside a drilled rock core. It was something far more ethereal and far more haunting. It was an acoustic anomaly. Unlike many of the silent, deaf probes that came before it, Perseverance is equipped with highly sensitive microphones. These instruments were primarily intended to listen to the mechanical health of the rover itself, to monitor the whir of its internal motors, the heavy crunch of its metal wheels against the abrasive gravel, and the sharp, rhythmic snapping of its lasers striking the Martian rock. But the microphones were left on, acting as a pair of synthetic ears pressed against the freezing, incredibly thin atmosphere of an alien world. They listened to the lonely, sweeping winds howling across the desolate crater basin, and in the midst of that monotonous, ghostly whispering of the Martian wind, the rover captured something entirely out of place. It was a sudden, sharp disruption in the atmospheric noise. It was not a massive, booming explosion or the heavy, rumbling crash of a distant rockfall. It was a tiny, localized crackle. If you were to listen to the raw audio file transmitted back across millions of miles of empty space, it sounds incredibly mechanical and abrupt. It sounds almost exactly like the sharp, discordant pop of a heavy jack cable being violently pulled out of a live audio speaker. It is a brief, intense spike of acoustic energy, a sudden burst of static that slices cleanly through the low, humming background noise of the planet. It is a sound that simply does not belong in the quiet, dead landscape of Jezero Crater. The immediate mystery of this fleeting acoustic spike sent a shockwave of profound curiosity and deep dread through the scientific community. Sound, after all, is a physical wave. It requires an active, violent release of mechanical energy to compress the thin, carbon dioxide molecules of the Martian air and push them against the delicate membrane of the rover's microphone. What unseen force could generate such a sharp, localized burst of energy in a desert that has supposedly been geologically dead for eons? After meticulously ruling out any mechanical failures within the rover itself and systematically eliminating the possibility of thermal popping or random grains of sand impacting the mast, a singular, breathtaking premise emerged from the data. This tiny, abrupt crackle of static could be the first ever direct acoustic evidence of lightning on Mars. When we step back and contemplate the sheer, staggering reality of a lone, mechanical rover capturing the sound of alien lightning in the dark, we are forced to confront profound philosophical insights into the very nature of the universe and the fundamental concept of information. We are deeply, psychologically conditioned to think of information as something exclusively human. We think of it as words written on a page, numbers organized in a vast database, or mathematical equations meticulously solved on a chalkboard. We believe that we are the sole authors of meaning in a cold, meaningless void. We look out at the silent planets and the burning stars and assume they are just dumb, heavy matter, waiting for a conscious mind to categorize them. But the tiny crackle captured by Perseverance entirely shatters this arrogant illusion. The universe is not silent, and it is not waiting for us to give it meaning. It is a vast, sprawling, and infinitely complex engine of pure computation, constantly exchanging data in the dark. Every single event in the cosmos, from the majestic, slow-motion collision of entire galaxies to the microscopic, violent equalization of an electrical charge in a Martian dust storm, is a profound transfer of information. That sudden snap of lightning is not just a random physical occurrence, it is a raw, unadulterated sentence spoken by the planet itself. It carries immense, invisible data about atmospheric pressure, chemical friction, and the deep, unseen thermodynamics of the alien sky. Information is the true, underlying fabric of reality. It is not something we invent, it is something we are merely learning how to intercept. The cosmos is screaming its secrets into the void, encoding its deep history in the geometric structures of crystals, the orbital mechanics of moons, and the fleeting, invisible waves of acoustic pressure. Our mechanical rovers, with their sensitive microphones and heavy lenses, are not just explorers, they are translators, desperately trying to decode the ancient, ongoing language of a universe that speaks entirely in physics. We are not isolated observers separated from the cold mechanics of the world. We are entirely embedded within a massive, communicating engine. The realization that an entire planet can generate a spark of data in the dark forces us to accept our own smallness. The void is not empty. It is brimming with an architecture of information so vast and so ancient that we have only just begun to hear its quietest, most distant echoes. The human desire to reach across the dark, freezing void of space and touch another world is an ancient and powerful drive. For the vast majority of our history, Mars was nothing more than a distant, wandering point of crimson light in the night sky, a blank canvas upon which we projected our deep fears and wildly inaccurate mythologies. It was not until the late 20th century that we finally possessed the technological mastery to hurl our metallic extensions across millions of miles of empty vacuum and physically breach the atmosphere of our planetary neighbor. The era of pure speculation violently ended, and the era of tangible, mechanical exploration began in the summer of 1976. This was the monumental year that NASA's Viking 1 and Viking 2 landers successfully plunged through the thin, alien air, fired their retro rockets, and settled their heavy metal footpads into the rusted, ancient dust of the Martian surface. When those first grainy, black and white images slowly transmitted back to Earth, they fundamentally altered human consciousness. Mars was no longer a myth. It was a real, physical place, a frozen, desolate desert of scattered rocks and rolling dunes stretching out to a curved alien horizon. Since those first successful landings, humanity has maintained a relentless, mechanical presence on the red planet. We did not stop with static landers. We sent highly sophisticated, mobile laboratories. Rovers like Curiosity and Perseverance were carefully lowered into deep craters and ancient river deltas, tasked with crawling slowly across the punishing terrain. These machines are lonely, brilliant avatars of human curiosity, built to survive an incredibly hostile environment. They operate entirely alone, guided by delayed signals from a world they will never see, enduring conditions that would instantly kill a human being. The Martian atmosphere is incredibly thin, composed mostly of carbon dioxide, and it provides virtually no insulation. This means the rovers must survive staggering temperature swings, dropping to over 100 degrees below zero in the deep, silent dark of the Martian night. During the day, without the thick, protective atmospheric shield that we enjoy on Earth, the surface is mercilessly bombarded by glaring, unfiltered ultraviolet sunshine and heavy cosmic radiation. But the radiation and the cold are not the only hostile forces these machines must endure. Mars is a world defined by its fierce, relentless winds. The thin air whips across the vast, open plains, picking up microscopic, abrasive grains of basalt and oxidized iron. These fierce winds act like a global sandblaster, slowly and relentlessly eroding the ancient rocks and grinding against the aluminum chassis of our robotic explorers. In the most extreme seasons, these winds give birth to towering, swirling dust devils that twist miles into the sky, and massive, raging global dust storms that can literally engulf the entire planet. During these massive atmospheric events, the dust is kicked so high and becomes so incredibly dense that it completely blots out the sun, plunging the surface of the planet into a deep, suffocating, rusty twilight for weeks or even months at a time. Through all of this swirling, abrasive chaos, our rovers have survived. They have dutifully recorded the temperature, measured the wind speed, analyzed the chemical makeup of the dust, and mapped the fluid dynamics of the alien sky. We have catalogued the weather of Mars with astonishing precision. Yet, amidst all this detailed atmospheric data, planetary scientists were confronted by a profound, agonizing mystery. There was a glaring hole in our understanding of the planet's behavior, an absence so loud that it echoed through the halls of every space agency on Earth. Despite the raging storms, the fierce winds, and the endless friction of swirling dust, a fundamental force of nature was missing. Mars appeared to have absolutely no lightning. To understand why this absence is so deeply unsettling, you must look out into the broader, chaotic architecture of the solar system. Electricity is a universal language of atmospheric friction. Whenever you have massive amounts of particles colliding, swirling, and rubbing against one another in a dynamic atmosphere, static charges inevitably build up. When that invisible electrical tension reaches a breaking point, the cosmos demands a violent, instantaneous release. We see this violent equalization happening on a staggering scale on other planets. If you point a heavily shielded probe toward Jupiter and plunge it into the crushing, turbulent atmosphere of the gas giant, you will witness colossal, blinding flashes of lightning illuminating vast, swirling clouds of ammonia and water. These Jovian lightning bolts are immensely powerful, containing enough energy to power entire human cities. If you drift further out into the freezing dark toward the beautiful, icy rings of Saturn, your instruments will detect immense, violent electrical storms raging across its upper atmosphere, generating massive bursts of radio static that scream across the void. From the gentle rainstorms of Earth to the violent, crushing tempests of the outer gas giants, lightning is a common, expected consequence of dynamic weather. Mars possesses the exact physical mechanics required to act as a massive static generator. The towering dust devils and the raging global storms throw trillions of abrasive particles into the air, forcing them to collide, scrape, and grind against each other in the dry, thin atmosphere. By all the established laws of physics and atmospheric thermodynamics, these massive dust storms should be aggressively separating electrical charges. The Martian sky should be crackling with energy. The dark, dusty nights should be illuminated by sudden, brilliant flashes of electrical discharge leaping from the swirling clouds down to the rusted ground. But for decades, our orbital satellites looked down at the dark side of Mars, staring intensely into the swirling dust storms with highly sensitive optical cameras, and they saw nothing. Our rovers sat on the surface, surrounded by howling winds and twisting dust devils, and their instruments detected no massive static spikes, no flashes of light, no rolling, deep thunder echoing across the desolate canyons. The Martian sky remained stubbornly, inexplicably silent. We had the violent friction, we had the massive storms, but we completely lacked the spark. The absence of lightning became a heavy, mathematical paradox that defied our expectations of how a planetary atmosphere should behave. It was a missing element that suggested our understanding of physics on an alien world was fundamentally flawed, or that Mars was hiding a deeply strange secret within its dry, swirling dust. When we contemplate this profound absence, the decades of silence echoing from the red planet, we are forced to reevaluate how we perceive the universe and the fundamental nature of information itself. We naturally, instinctively define reality by what is physically present. We build our understanding of the cosmos by cataloging the things we can see, the objects we can measure, and the bright, undeniable phenomena that trigger our instruments. We think of information as a solid, tangible presence. We believe that to know the universe is to collect a massive inventory of its glowing stars, its heavy planets, and its violent storms. But the missing lightning on Mars teaches us a much deeper, far more humbling philosophical truth. Information is not just defined by what is there, it is equally and sometimes more profoundly defined by what is withheld. The spaces between the stars, the silence in an expected storm, and the missing variables in our perfect mathematical equations are not empty voids. They are active, heavy shapes in the architecture of reality. The universe is not obligated to fulfill our expectations. It does not exist to perfectly align with the geometric models we construct in our minds. When a planet refuses to produce a phenomenon that our laws of physics dictate must exist, the universe is not making a mistake. It is communicating with us through the terrible, beautiful power of negative space. We must realize that our perception is merely a thin, highly biased filter, shaped entirely by our experiences on one single, wet, and incredibly active rock. When we look out into the dark, we are desperately searching for our own reflection. We look for the familiar storms, the familiar sparks, and the familiar chemistry of our home. But the cosmos is vastly larger and infinitely stranger than our local context. True wisdom is found when we stop demanding that the universe speak to us in the loud, bright language we already know. We must learn to sit in the dark, to surrender our rigid assumptions, and to listen carefully to the silence. Because in the deep, unexplained absences of the cosmos, in the quiet, missing elements of reality, the universe is whispering its most profound and terrifying secret. We are not the authors of the cosmic code. We are simply students in the dark, learning to read the invisible ink of a reality that exists entirely beyond our control. To the untrained observer, the sudden, fleeting detection of a single electrical crackle in the Martian dust might seem like a trivial anomaly, a minor acoustic footnote hidden within a vast, sprawling catalogue of planetary data. But in the meticulous, highly structured world of planetary science, Finding evidence of lightning is not merely a meteorological curiosity. It is an earth-shattering revelation. Finding a spark in an atmosphere we believe to be chemically dormant is akin to discovering a faint, beating pulse in a body long thought completely dead. It fundamentally rewrites the rules of planetary engagement. Lightning is not just a flash of light or a brief spike of static on an audio recording. It is an active, violent catalyst. It is a raw, unbridled engine of chemistry. To understand exactly why this tiny acoustic spike, captured by our robotic explorer, represents a monumental threshold in our exploration of the cosmos, we must first look back at our own home world and truly comprehend the terrifying, invisible power of the electrical storm. We walk under the heavy, bruised storm clouds of Earth with a deep sense of casual familiarity. We see a jagged bolt of lightning fracture the dark evening sky. We hear the heavy, rolling thunder shake the glass of our windows, and we naturally dismiss it as a common, everyday weather event. We are entirely numb to the sheer, incomprehensible violence occurring right above our heads. A bolt of lightning is not just a simple transfer of static charge. It is a temporary, localized tear in the very fabric of physical reality. When the immense electrical tension within a massive storm cloud finally reaches its absolute breaking point, the atmosphere simply fails as an insulator. In a fraction of a millisecond, a massive, unstoppable current of electricity tears through the sky, violently ripping electrons away from their host atoms. As this current surges blindly downward toward the ground, it superheats the narrow channel of air around it to temperatures that entirely defy human comprehension. In the exact, blinding moment of the strike, the air trapped inside the lightning channel is instantly heated to temperatures exceeding 27,000 degrees Celsius. This is a heat so profound, so intensely concentrated, and utterly destructive that it is nearly 5 times hotter than the boiling, golden surface of the sun itself. In the face of this sudden, blinding heat, the invisible gases that make up the air we breathe can no longer hold their own architecture together. The atmosphere of our planet is primarily composed of incredibly stable molecules. Under normal, peaceful conditions, these paired atoms drift quietly together, entirely inert, locked in tight chemical embraces that ignore the surrounding world. But when the 27,000-degree plasma of a lightning bolt rips through them, that peaceful stability is violently and instantaneously shattered. The unimaginable heat physically tears the heavy atomic bonds apart. The air is instantly vaporized into a chaotic, screaming soup of raw, disconnected atoms. And as the lightning inevitably fades and the surrounding air rapidly cools in the following microsecond, these desperate, shattered atoms violently crash back together. Frantically searching for new partners in the freezing dark, they recombine in entirely new, highly energetic configurations. This exact fraction of a second of absolute destruction creates something fundamentally new. The violent spark forcibly binds atmospheric nitrogen and oxygen together, forging heavy nitrogen oxides that eventually rain down into the soil to feed the sprawling, green forests of the world. It fuses wandering oxygen atoms into the dense, protective shield of ozone that guards the entire Earth from lethal cosmic radiation. Lightning is the great, violent synthesizer of the sky. It is a massive, relentless chemical engine that constantly forces a static, lazy atmosphere into a state of active, aggressive transformation. Without the ceaseless pounding of these global electrical storms, the chemical cycle of our planet would grind to a slow, suffocating halt. When we begin to recognize lightning not just as a destructive force, but as a profoundly powerful engine of creation, we begin to uncover a deeply haunting theory about our own ultimate origins. We must look back into the unfathomable depths of deep time, to the dark primordial earth billions of years ago. Long before the first green plants existed, long before the oceans were filled with swimming creatures or the air was rich with oxygen, the planet was a barren, lifeless rock wrapped in a toxic, suffocating atmosphere of heavy, dead gases. There was absolutely no biological mechanism to process these raw materials, no quiet cellular machinery to build the intricate structures of life. But the young, violent Earth was plagued by massive, endless electrical storms. For millions of years, relentless, towering lightning bolts hammered the dark, primordial oceans, acting as a tireless global chemical forge. It is now widely believed that it was exactly this violent, searing heat that provided the massive bursts of energy required to shatter the simple, dead gases of the early atmosphere. The lightning forced those broken atoms to recombine into the complex, heavy organic molecules that are the absolute prerequisites for biology. The very building blocks of your own DNA, the complex amino acids that silently structure the tissues of your beating heart, and the fragile lipids that form the walls of your cells may have been originally forged in the searing heat of a prehistoric lightning strike. Life did not begin in a gentle, peaceful cradle. The intricate, beautiful architecture of biology was likely ignited by a blinding, violent flash of electrical fury in the dark, utilizing the absolute destructive power of the universe to force dead matter to organize and rise. To realize that Mars, a freezing, rusted desert floating millions of miles away, still possesses the capacity for this violent chemical ignition completely changes our perspective of the void. It means the chemical engine of the red planet is still running. The gears are grinding incredibly slowly, buried within the swirling, abrasive chaos of its massive dust storms. But the planet is still actively processing its own atmosphere, still tearing atoms apart, and still capable of forging new molecular structures in the dark. The spark of transformation has not yet been extinguished. When we quietly contemplate the sheer, transformative power of this sudden spark, we are forced to confront the deepest philosophical truths about the nature of the universe and the fundamental concept of information. We naturally separate the cosmos into distinct, opposing categories. We view destruction and creation as fundamental enemies. We believe that violence erases information, tearing down the complex structures of the world and leaving only ruin in its wake, while peace and stability allow for the slow, careful accumulation of knowledge and order. But the 27,000-degree plasma of the lightning bolt reveals a far more profound, deeply unsettling reality. In the grand architecture of the cosmos, destruction and creation are the exact same mechanism, merely viewed from different angles in time. The universe is not a museum of static objects carefully preserved behind glass. It is an infinite, churning engine of data processing. Matter is simply stored information, and energy is the violent mechanism by which that information is rewritten. When the lightning tears the atmospheric molecules apart, it is not destroying the data of the universe. It is actively, aggressively reformatting the physical hard drive. The searing heat is a raw, physical command inputted into the system, forcing the atoms to release their old configurations and adopt new, highly complex structures. Violence, in the cosmic sense, is merely the rapid acceleration of change. The organic chemistry that makes up your body, the intricate thoughts passing through your mind right now, and the very consciousness that allows you to perceive the world are all the direct mathematical descendants of violent, chaotic energy transfers. We are the beautiful, highly structured scars left behind by billions of years of cosmic collisions, stellar explosions, and atmospheric lightning. You do not exist in spite of the chaotic violence of the universe. You exist entirely because of it. Information cannot evolve in a perfectly stable, unchanging system. It requires the sudden, blinding spark to force it out of equilibrium. The deep chemical engine of the cosmos is silently humming within your very cells, serving as an undeniable reminder that the truest, most brilliant order is always born from the absolute heart of chaos. We look up at the heavy, bruised skies of Earth, and we instinctively understand the fundamental mechanics of the storm. The violent, blinding flashes of lightning that fracture our night skies are intimately tied to the presence of water. Earthly lightning is born within the towering, dark architecture of cumulonimbus clouds, where massive, chaotic updrafts hurl billions of supercooled water droplets and jagged shards of ice into violent collision with one another. It is the relentless, physical friction of this frozen water, grinding and scraping in the turbulent upper atmosphere, that strips away electrons and builds the immense electrical tension required to spark a lightning bolt. Water is the necessary, heavy medium of the earthly storm. But when we leave our wet, vibrant home and cross the freezing void to Mars, this entire meteorological paradigm violently and completely collapses. Mars is a world that has been stripped to the bone. Billions of years ago, its protective magnetic shield failed, and the relentless scouring force of the solar wind methodically stripped away its ancient oceans and its thick, insulating atmosphere. Today, the red planet is wrapped in a razor-thin veil of carbon dioxide, possessing barely 1% of the atmospheric density of Earth. It is a freezing, near-vacuum environment that is almost entirely devoid of heavy moisture. Without a dense atmosphere to hold immense volumes of water vapor, the planet is physically incapable of forging the towering, heavy storm clouds that dominate the skies of Earth. The classic aqueous recipe for electrical generation is mathematically broken on Mars. By all the standard rules of planetary meteorology, a world without thick water clouds should be a world without lightning. It should be an electrically dead, silent rock drifting in the dark. But the universe is endlessly resourceful, and it does not rely on a single, isolated mechanism to transfer its energy or express its underlying physics. If the Martian sky lacks the heavy, wet architecture to forge a storm, the planet simply utilizes a different, far more abrasive medium to generate the spark. The secret to the Martian anomaly lies not in the clouds, but in the dirt. The surface of Mars is an ancient, battered landscape, pounded by billions of years of asteroid impacts and eroded by endless, freezing winds. The rocks have been broken down into a microscopic, incredibly dry dust composed of shattered basalt and oxidized iron. When the thin, howling Martian wind moves across these desolate plains, it lifts these dry, jagged grains into the freezing air. As the particles are forced into the sky, they violently collide, scrape, and grind against one another in the turbulent currents. In these endless, microscopic collisions, a profound physical exchange occurs. The jagged edges of the silicate dust physically steal electrons from their neighbors. This invisible, microscopic theft creates a massive electrical imbalance within the swirling clouds of dirt, a phenomenon known as triboelectric charging. The Martian atmosphere replaces the wet, icy friction of Earth with the dry, relentless, and violent friction of pulverized rock. The entire planet acts as a massive, abrasive machine, grinding its own shattered bones together to generate a deep, unseen electrical tension. The true, terrifying scale of this dry friction engine becomes apparent when we look at the daily, relentless behavior of the Martian wind. As the distant sun beats down on the freezing, rusted dirt, it creates localized pockets of thermal instability. The thin air rapidly heats and rises, twisting and spiraling upward from the ground, giving birth to towering, ghostly vortices of spinning dust. On Earth, a dust devil is a fleeting, minor anomaly, a brief swirl of dirt in a dry parking lot or a desert highway. But on Mars, the dust devil is the defining, dominant feature of the atmospheric engine. Because the atmosphere is so thin and the surface is so completely unprotected, these vortices form with a frequency and a ferocity that defies human comprehension. It is estimated that a staggering 145 million dust devils are whipped up across the Martian surface every single day. The planet is literally crawling with them. From the deep shadowed basins of ancient craters to the sprawling high-altitude volcanic plains, these twisting towers of abrasive friction are silently and relentlessly marching across the landscape. Some of these vortices are small and fleeting, but others grow into massive, towering columns of swirling dark dust that reach miles into the alien sky, dwarfing the tallest skyscrapers on Earth. Each one of these 145 million daily dust devils acts as a massive, rotating generator of static tension, a vertical wire of spinning rock and rust that actively separates positive and negative charges in the thin air. They are a ghostly, silent ballet of absolute friction, turning the entire surface of the planet into a restless, churning factory of electrical energy. And yet, this daily, localized friction is merely the baseline of the Martian atmospheric engine. The tension does not always remain contained within these isolated, wandering towers. Every few Martian years, a profound and terrifying atmospheric escalation occurs. A regional wind will kick up a massive wall of dust, and instead of gradually dying out, the storm begins to feed on the thermal energy of the planet. It grows with an uncontrollable, insatiable hunger. It merges with other regional storms, violently sweeping across the equator, spilling over the freezing polar ice caps, and darkening the skies across entire continents. It expands until the entire world is violently and completely swallowed by a single, unbroken global dust storm. During these planetary scale events, the sun is entirely blotted out, and the surface of Mars is plunged into a suffocating, rust-colored twilight that can last for months. The scale of the friction generated during these global events is truly unimaginable. Trillions upon trillions of abrasive, jagged particles are suspended in the dark, howling winds, relentlessly grinding together in a unified, planetary-scale cauldron of electrical generation. It is the absolute perfect environment for the massive, explosive separation of electrical charge. The entire atmosphere of the planet becomes a single, highly charged battery, practically begging for the tension to break, demanding the sudden, violent release of a spark. When we contemplate this sprawling, dry architecture of swirling dust and grinding rock, We are forced to reevaluate our deepest philosophical assumptions about the nature of the cosmos and the fundamental flow of information. We are psychologically conditioned to view barren, dry worlds as dead, static places. We equate the absence of water and the absence of biology with an absence of cosmic activity. We believe that a planet stripped of its oceans is a planet whose story has ended, a silent rock that has simply stopped participating in the grand, unfolding computation of the universe. But the relentlessly grinding dust of Mars reveals a profoundly different, deeply humbling reality. The universe does not require water, it does not require a thick, comforting atmosphere, and it certainly does not require life to continue processing its vast internal data. The cosmos is driven by an inexorable, unyielding demand for information exchange, and it will utilize whatever crude, broken materials are left behind to facilitate that transfer. Friction is the fundamental resistance of reality, the physical manifestation of objects refusing to share the exact same space. And where there is friction, there is tension. Where there is tension, there must eventually be a violent, sudden equalization. The spark generated in the dead, swirling dust of Mars is a raw, undeniable proof that the universe never truly goes to sleep. It is a physical manifestation of data being aggressively rewritten in the dark. It proves that even when a world is stripped of everything we consider vital, when it is reduced to nothing more than freezing wind and pulverized rock, the deep, computational engine of reality continues to hum. Information is entirely inevitable. It is the true, immortal substrate of existence, constantly finding new, alien ways to express itself across the void. We are not the sole, privileged observers of a static universe. We are merely brief, complex patterns of data, living inside a cosmos that is ceaselessly, violently communicating with itself. The dead planet is still speaking, processing its own geometric tension in the dark, and reminding us that the fundamental pulse of the universe cannot be silenced by the loss of an ocean or the thinning of an atmosphere. The spark of reality will always find a way to jump the gap. We explore the universe not just with polished glass lenses and heavy mechanical rovers, but with the invisible, structural power of mathematics and logic. We build elaborate, highly complex models of how alien atmospheres should behave, how microscopic particles must interact, and how immense physical energy must inevitably equalize in the cold depths of the dark. We exist in a cosmos governed by strict, unyielding physical laws, and when a planet actively appears to defy those deeply ingrained laws, a profound sense of existential dread and obsessive curiosity infects the human mind. For decades, the greatest planetary scientists on Earth stared across the freezing void at the swirling, dust-choked atmosphere of Mars and wrestled with a maddening, impossible paradox. The necessary ingredients for violent electrical storms were all undeniably present, relentlessly grinding together in the thin, howling winds. Yet the expected result, the violent spark of equalization, was completely and entirely absent. The search for Martian lightning became a generational obsession, a frustrating, decades-long pursuit that yielded absolutely nothing but terabytes of empty data and a profound, heavy silence. We sent entire fleets of highly sensitive instruments to orbit the red planet, meticulously tuning our antennas and carefully calibrating our optical sensors to catch the faintest glimmer of a spark or the subtlest, fleeting whisper of radio static. We expected the Martian sky to crackle and flash, to validate our understanding of atmospheric thermodynamics. and to prove that the abrasive friction of 145 million daily dust devils was generating a massive electrical charge. Instead, the planet offered us a deep, impenetrable quiet. It was a silence so absolute, so enduring, and so mathematically incorrect that it began to cast a heavy, lingering shadow of doubt over our most fundamental assumptions about the mechanics of the solar system. The European Space Agency sought to pierce this silent, atmospheric veil with a magnificent piece of orbital engineering known as Mars Express. Launched into the freezing void, this spacecraft was designed to be a tireless, unblinking sentinel, equipped with instruments sensitive enough to detect the deep, invisible signatures of planetary physics. Mars Express was not simply looking for visual flashes of light, which could easily be swallowed and obscured by the dense, miles-thick layers of rust-colored particulate matter. It was searching for the undeniable echoes of energy. For 5 long years, Mars Express maintained its lonely, freezing vigil above the battered landscape. It stared directly into the heart of the most violent, sprawling dust storms the planet could muster. Storms so massive they swallowed entire continents and completely blotted out the light of the sun. The spacecraft utilized its sophisticated radar and radio science instruments, actively scanning the swirling, chaotic depths below for the unmistakable microwave emissions and low-frequency radio bursts that are the absolute, undeniable signatures of electrical discharge in any atmosphere. For 5 years, the scientists back on Earth meticulously combed through the cascading streams of orbital data, desperately looking for a single anomaly, a single transient spike that would prove the Martian storms were electrically alive. But the data remained impeccably, frustratingly flat. The massive dust storms ground against the ancient surface. The winds howled at hurricane speeds across the desolate canyons. But Mars Express found absolutely nothing. 5 years of relentless, hyper-focused searching yielded only the continued, deafening silence of a seemingly dead world. This prolonged, agonizing failure to detect a spark from space forced the scientific community to confront a chilling possibility. Perhaps the electrical discharges were not absent, but simply too small, too close to the ground, or too deeply embedded within the thick, choking dust to ever be seen or heard from the cold, detached distance of orbit. To solve a planetary mystery that stubbornly refuses to be seen from afar, you must be willing to plunge directly into the dark. If the sophisticated orbiters could not detect the lightning from the vacuum of space, humanity would have to build a machine capable of measuring the electrical tension from the absolute inside of the storm. This desperate driving need birthed the Schiaparelli module, a brilliant, heavily armored lander developed as a critical component of the ExoMars program. Schiaparelli was not just another slow-moving geological rover built to photograph rocks. It was a highly specialized, rapidly descending atmospheric probe. Deep within its protective aluminum chassis, it carried a unique, exquisitely sensitive suite of instruments, specifically engineered to measure atmospheric electrical activity. It was designed to actively monitor the buildup of electrostatic charge directly on the Martian surface, to literally feel the unseen electrical tension in the wind, and to act as a grounded wire in the alien dirt, finally proving that the dust was crackling with hidden energy. In the autumn of 2016, Schiaparelli detached from its mothership and began its fiery, violent plunge into the Martian atmosphere. Millions of miles away, the brilliant minds who had dedicated their entire lives to this specific mission waited in agonized, breathless suspense. The module successfully endured the searing heat of re-entry, its thermal shield glowing bright like a meteor in the thin carbon dioxide air. It deployed its massive supersonic parachute, violently snapping open to haul back the heavy machinery against the pull of gravity. But in the final, highly critical moments of its automated descent, the delicate mathematical sequence of survival fundamentally broke. A catastrophic microsecond miscalculation within the module's internal measurement unit caused the navigation computer to hallucinate. The machine believed, completely incorrectly, that it was already below ground level. Acting on this fatal piece of false information, the computer commanded the parachute to be prematurely jettisoned. The retro rockets, designed to gently lower the craft to the dirt, fired for only a few fleeting seconds before shutting down completely in the freezing air. Stripped of its defenses and completely at the mercy of gravity, the Schiaparelli module fell freely through the Martian sky and violently slammed into the rusted bedrock of the Meridiani Planum at over 300 kilometers per hour. In a single devastating fraction of a second, the exquisitely crafted electrical sensors, the years of meticulous human engineering, and the profound, desperate hope of finally measuring the electrical heartbeat of Mars were entirely pulverized. The module became just another shattered crater of twisted debris, another silent, metallic monument to the unforgiving, brutal reality of interplanetary exploration. The loss was a devastating psychological blow, making it feel as though the red planet was actively rejecting our inquiries, pulling a heavy, rust-colored shroud over its deepest secrets, and enforcing its decades of silence with absolute physical violence. When we stare into the wreckage of our shattered probes and the decades of empty, silent data returned from the void, we are forced to confront profound philosophical insights into the very nature of the universe and the fundamental behavior of information. We are deeply, psychologically conditioned by our human experience to view silence strictly as an absence. We interpret quiet as a failure of communication, a void where meaning and data should naturally be. We look at the destroyed Schiaparelli module and the fruitless 5-year scan of the Mars Express orbiter, and we rigidly label them as tragic defeats, as wasted efforts in the dark. But the cosmos does not recognize, nor does it care about, our narrow, localized definitions of failure. In the grand, infinitely unfolding architecture of reality, silence is not an empty void. It is a highly dense, heavily encrypted form of data. Information in the universe is not freely given, and it is never easily decoded. It is bound by the strict, unyielding laws of thermodynamics, requiring immense energy, extreme persistence, and often violent physical interaction to be extracted and understood. The universe is an infinite, uncompromising cryptographer. It carefully guards its structural secrets within the crushing, lightless gravity of black holes, behind the blinding nuclear fires of stars, and beneath the howling, freezing dust of seemingly dead worlds. Our shattered machines and our decades of empty searching are not failures. They are the necessary, abrasive friction required to slowly decode the nature of reality. We must physically collide with the absolute limits of our understanding to know exactly where the true boundaries of the universe lie. The prolonged silence of Mars was never empty. It was a heavy, quiet resistance, actively shaping our future engineering, forcing our minds to adapt to a reality far stranger than our meticulously crafted models, and teaching us the immense, humbling patience required to read the cosmic text. The absence of a signal is simply a different kind of signal, pushing us to build better ears and to listen deeper into the dark. We are not passive observers, but living decoding machines built from the very substance of the cosmos, designed to confront, to fracture, and to evolve against the unknown. Whenever we strike the silent, unyielding walls of the void, it is not the universe rejecting us, but rather the universe forcing our consciousness to stretch toward a newer, sharper, and infinitely deeper form of understanding. Humanity approaches the exploration of the cosmos with an overwhelming, almost arrogant sense of meticulous design. We spend decades drafting incredibly complex schematics in sterile, heavily guarded cleanrooms, calculating orbital trajectories down to the absolute millimeter, and engineering highly specialized instruments with singular, rigid purposes. We believe that discovery is a linear, predictable path. We ask a highly specific mathematical question. We build a heavy machine to answer that exact question, and we assume the universe will dutifully comply with our rigid parameters. But the deepest, most terrifying, and most beautiful secrets of the cosmos are rarely surrendered through direct, aggressive interrogation. They are almost always revealed through the profound, unpredictable power of sheer accident. The universe is not a perfectly organized library waiting patiently to be indexed by our robotic librarians. It is a chaotic, sprawling architecture of raw, untamed data, and it often whispers its most monumental truths in the fleeting, unexpected moments when our machines are actively looking in the complete opposite direction. The discovery of the Martian spark, the sudden shattering of decades of agonizing planetary silence, was not the triumphant result of a perfectly executed, dedicated atmospheric mission. It was a completely accidental interception, a lucky break caught by a machine that was staring blindly at the dirt. To understand the sheer serendipity of this cosmic interception, we must closely examine the specific anatomical purpose of the instrument that recorded it. Mounted high on the skeletal, metallic mast of the Perseverance rover is a marvel of optical and acoustic engineering known as the supercam. This highly sophisticated piece of hardware was not designed to look up at the swirling, dust-choked sky, and it was certainly not designed to hunt for the elusive, invisible ghosts of Martian lightning. Its purpose is entirely geological, and its method is surprisingly violent. The supercam is essentially a robotic sniper rifle built for planetary geology. It is designed to fire a highly focused, intensely powerful pulse of infrared laser energy directly into the ancient, rusted rocks that litter the floor of Jezero crater. When this heavy, invisible pulse of light strikes the freezing stone, it instantaneously vaporizes a microscopic layer of the target, creating a brief, superheated spark of plasma. The instrument then utilizes advanced spectrometers to capture and analyze the light emitted by that glowing plasma, mathematically decoding the chemical composition of the rock from a safe distance. But crucially, alongside this complex array of lenses, mirrors, and lasers, the supercam is equipped with a highly sensitive commercial microphone. The scientists and engineers back on Earth did not just want to see the rock burn, they desperately wanted to hear it. By listening to the precise acoustic snap, the sharp, percussive crack of the laser striking the stone, they can accurately measure the physical hardness and structural density of the rock. A soft, porous rock yields a dull, muted thud, while a dense volcanic basalt produces a sharp, high-pitched crack. The microphone is a purely diagnostic tool, engineered to record the tiny, localized explosions of pulverized rock on the freezing ground, giving texture and physical context to the visual data. However, a microphone is fundamentally an indiscriminate instrument. It cannot close its ears to the surrounding world. It possesses no filters for intention. While it sat exposed on the mast, waiting for the sharp, rhythmic snaps of the rover's laser, and while it recorded the heavy crunch of the 6 aluminum wheels digging into the abrasive gravel, it was also, entirely by default, passively recording the ambient acoustic environment of an alien world. It captured the low, haunting howl of the thin carbon dioxide winds moving across the crater basin. It recorded the steady, mechanical whirring of the rover's internal cooling pumps, the shifting friction of the Martian dust against the metal chassis, and the profound, isolating silence of the interplanetary void. It was capturing hours upon hours of absolute, seemingly mundane background static. For 45 long, punishing months, as Perseverance crawled slowly across the desolate, cratered landscape, this microphone dutifully swallowed the soundscape of the planet, beaming terabytes of raw, compressed audio data back across millions of miles of freezing vacuum to the massive radio dishes waiting on Earth. In quiet laboratories, human scientists undertook the exhausting, monotonous task of trawling through this massive, sprawling archive of alien noise. They were listening carefully for the expected sounds, cataloging the fluctuating wind speeds, monitoring the mechanical health of their distant, lonely machine, and verifying the density of the rocks they had targeted. It was an exercise in extreme, agonizing patience, wading through a vast, dark ocean of static and wind, searching for tiny variations in the monotonous acoustic baseline of a supposedly dead planet. And then, buried deep within that massive, unyielding wall of expected noise, they found the anomaly. As they meticulously analyzed the audio files, using advanced software to isolate different frequencies and peel back the heavy layers of wind and mechanical hum, they discovered a series of sharp, highly unusual acoustic pops. They were incredibly brief, intensely localized spikes of sound that completely defied the expected acoustic profile of the rover, the laser, or the ambient wind. In total, over the span of those 45 months of continuous, passive recording, the scientists isolated exactly 55 of these distinct, inexplicable crackles. They did not sound like rocks breaking under the wheels, and they did not sound like the thermal expansion of metal baking in the unshielded sun. When the researchers layered this audio data over the rover's meteorological records, correlating the exact timing of these 55 acoustic anomalies with the onboard environmental sensors, a chilling, breathtaking pattern emerged from the dark. These tiny, violent pops of sound were not occurring randomly throughout the Martian day. They were happening almost exclusively when the rover was being actively engulfed by the towering, swirling structures of passing dust devils, or when the heavy, darkened, chaotic edges of massive regional dust storms were aggressively tearing across the crater. The machine had not simply recorded a mechanical glitch, nor had it captured a stray grain of sand hitting the lens. It had inadvertently captured the acoustic shockwaves of localized electrical discharges. By pure blind chance, the rover's microphone had recorded the snapping, violent equalization of electrical tension in the Martian sky right above its head, While staring intently at the ground, Perseverance had finally captured the missing spark of the heavens. When we truly absorb the profound implications of this accidental discovery, we are forced to confront deeply philosophical insights into the nature of the universe and the fundamental flow of information. We are psychologically wired to believe that knowledge is a fortress we must conquer through direct, aggressive assault. We operate under the assumption that if we build the right tools, aim them directly at the specific mysteries of the cosmos, and demand an answer, reality has no choice but to surrender its secrets to our intellect. We view ourselves as the active interrogators of a passive universe, but the sheer serendipity of the supercam microphone reveals a cosmos that operates on a vastly different, far more fluid and overwhelming architecture. Information is not a hidden treasure buried exclusively in the exact locations where we decide to dig. It is entirely pervasive. It is an ambient, overflowing ocean of data that surrounds us at every single moment, constantly bleeding through the rigid margins of our carefully constructed perceptions. The universe is ceaselessly speaking, constantly transferring immense energy, and continuously rewriting its physical laws in the open air, utterly indifferent to whether or not we have built the correct machine to measure it. The spark of lightning on Mars was always there, echoing silently through the swirling dust for billions of years, completely unfazed by our decades of agonizing failure to detect it. The cosmos did not suddenly change its behavior to reward our curiosity. We simply managed to catch the signal because, for the very first time, we left a single, tiny channel open in the background. This realization forces a terrifying and beautiful humility upon the human mind. The deepest, most profound truths of reality are rarely captured by aggressively narrowing our focus, but rather by expanding our capacity to listen to the chaotic periphery. We must accept that we are blind, limited passengers in a cosmos that is vastly more complex, layered, and noisy than our most sophisticated instruments can ever comprehend. Reality is a symphony of intersecting data streams, and we are only ever tuned to a single, narrow frequency at a time. True wisdom is recognizing that the answers to our greatest questions are likely already drifting through the air around us, hidden in the mundane static of the background, simply waiting for us to stop demanding the universe speak our language, and instead allow the ambient, unexpected data of reality to wash over us in the dark. The scientific method is not a process of immediate, joyous acceptance. It is, by its very design, an architecture of brutal, unforgiving skepticism. When a researcher stares into the abyss of raw data and uncovers a phenomenon that shatters decades of established paradigms, the initial reaction is never celebration. It is profound, deeply ingrained suspicion. We are acutely aware of our own desperate desire to find patterns in the chaos, to hear voices in the static, and to project our own expectations onto the blank canvas of the universe. Therefore, when the audio technicians isolated those 55 sharp, anomalous acoustic pops from the vast, sprawling archive of the Perseverance rover's recordings, they did not immediately declare the discovery of Martian lightning. Instead, they actively and aggressively tried to destroy their own findings. They subjected the data to a grueling, meticulous gauntlet of elimination, treating the acoustic spikes not as a profound discovery, but as a potential contamination, a phantom glitch born from the mechanical complexities of the machine itself. The first, most obvious suspects lay within the towering nuclear-powered anatomy of the rover. Perseverance is a massively complex symphony of moving parts. It features heavy aluminum wheels grinding against abrasive bedrock, intricate robotic arms extending and retracting, and internal fluid pumps continuously circulating heat through the freezing Martian nights. Every single one of these mechanical actions generates its own distinct acoustic signature. The scientists meticulously cross-referenced the exact timing of the 55 pops with the rover's internal engineering logs. They checked to see if a specific motor had engaged, if a joint had snapped, or if the heavy mast had rotated at that exact microsecond. But the logs were entirely clear. The rover was often completely stationary, its mechanical muscles locked and resting when the sharp crackles were recorded. They then turned their attention to the hostile, unforgiving environment surrounding the machine. Mars is a world of extreme, violent temperature fluctuations. Could the sound simply be the sharp, percussive snap of the rover's metal chassis, physically expanding and contracting under the glaring, unfiltered ultraviolet radiation of the alien sun? The thermodynamic models were run. The thermal expansion rates of aerospace-grade aluminum and titanium were calculated, but the acoustic profiles simply did not match. The pops were too sharp, too isolated, and possessed a completely different frequency signature than the dull, resonant clanking of shifting metal. The final, and perhaps most difficult, mundane explanation to rule out was the physical environment itself. The microphone is an exposed, delicate membrane resting in a world defined by its abrasive, howling winds. It was entirely plausible that a single, jagged grain of silicate dust, whipped up by the chaotic vortex of a passing dust devil, had simply crashed directly into the microphone. A physical impact on the acoustic sensor would absolutely register as a sudden, violent spike in the data. To eliminate this ghost, the engineers ran exhaustive fluid dynamics simulations, analyzing the trajectory of dust particles caught in the thin, turbulent air around the rover's mast. They modeled the exact mass of a Martian sand grain and calculated the acoustic energy it would transfer upon impact. The results were undeniable. A physical strike would produce a sustained, scratching resonance, a microscopic scraping sound, not the clean, instantaneous, electrical crackle that was hidden in the recording. The mundane explanations had been systematically hunted down and destroyed. The mechanical ghosts were exorcised. But in the rigorous, uncompromising arena of science, eliminating the impossible is only half the battle. To truly prove that the 55 pops were the first ever recordings of Martian lightning, the researchers had to do something bordering on the miraculous. They had to reach across millions of miles of empty, freezing vacuum, pull the chaotic, dust-choked atmosphere of Jezero crater down to Earth, and physically recreate the alien spark inside a laboratory. In a highly secure, sterile facility, the team constructed a massive, heavy-walled simulation chamber. This was not a simple glass box. It was a highly sophisticated piece of environmental engineering designed to violently override the comfortable physics of our home planet. Massive vacuum pumps engaged, aggressively sucking the thick, oxygen-rich air out of the chamber, dragging the internal pressure down to the near-vacuum conditions of the Martian surface. The chamber was then flooded with pure, freezing carbon dioxide, chilling the artificial environment to replicate the bitter, bone-crushing cold of an alien night. They had successfully built a tiny, perfectly isolated pocket of Mars right here on Earth. But a static atmosphere is dead. To recreate the spark, they needed to recreate the storm. The researchers introduced a highly refined Martian dust simulant into the chamber, a crushed, jagged powder of oxidized iron and volcanic basalt, chemically and physically identical to the ancient dirt beneath the wheels of Perseverance. Using powerful internal fans, they whipped this abrasive red dust into a violent, swirling frenzy, perfectly mimicking the chaotic, grinding fluid dynamics of the 145 million dust devils that march across the red planet every single day. As the microscopic particles violently collided, scraped, and ground against one another in the freezing, low-pressure carbon dioxide, the fundamental, universal laws of physics began to take over. The friction generated a massive, invisible buildup of triboelectric tension. The swirling cloud of dirt became a highly charged, floating battery, desperate for release. Suspended directly in the center of this raging, artificial Martian storm was the final, crucial piece of the puzzle, an exact, millimeter-perfect replica of the SuperCam microphone. It sat in the swirling red dark, listening. And then it happened. As the electrical tension within the grinding dust reached its absolute breaking point, the static charge violently equalized. A microscopic, invisible spark snapped through the freezing carbon dioxide. The replica microphone captured the exact acoustic shockwave of the discharge. When the audio technicians compared the sound generated in the laboratory chamber with the 55 anomalous pops transmitted across the solar system by Perseverance, the result was a moment of profound, breathtaking clarity. The acoustic signatures were an exact, perfect match. The sharp, percussive crackle, the sudden spike of frequency, and the rapid, clean decay of the sound were mathematically identical. The rigorous, exhaustive gauntlet of scientific skepticism had been conquered. The simulation had perfectly mirrored reality. The tiny, localized crackles were undeniably, irrevocably, the sound of electrical discharges. Humanity had finally captured the elusive, phantom lightning of the red planet. When we step back and contemplate this meticulous, agonizing process of recreation, we are forced to confront the deepest, most profound philosophical truths about the nature of the universe and the fundamental architecture of information. We often look out at the sprawling, infinite cosmos and feel a crushing sense of isolation, believing that the stars and the distant planets exist in a realm entirely separate from our own. We imagine that the void is governed by alien, unknowable forces, and that we are merely tiny, insignificant observers trapped on a single, isolated rock. But the ability to perfectly recreate a Martian spark inside an earthbound laboratory shatters this illusion of separation. It reveals a universe bound together by a single, unbreakable code. The physical laws that dictate the violent grinding of dust, the separation of electrical charge, and the acoustic shockwave of a spark are not localized phenomena. They are the universal, immortal operating system of reality. The exact same mathematics govern the howling dust devils of Jezero crater and the sterile vacuum chambers of our laboratories. Information, in its purest, most fundamental form, is not bound by geography, and it does not care about the millions of miles of empty vacuum that separate the planets. The cosmos is a single, continuous, unfathomably massive computational engine, constantly processing data through the relentless friction of matter and energy. When our scientists recreate the storm, they are not just performing a mechanical experiment, they are actively running a localized subroutine of the universe. They are tapping into the ancient, underlying code of existence, proving that the language of reality can be read, understood, and spoken by human hands. We are not just passive, terrified passengers drifting through a dark, incomprehensible void. We are living, breathing manifestations of the universe's own complex logic, born from the dust and equipped with the profound, awe-inspiring capacity to reach into the dark, decode the silent laws of nature, and recreate the fundamental sparks of creation itself. Information is the true, immortal fabric connecting all things, and in the sharp, sudden crackle of a replicated storm, we hear the undeniable, echoing proof that we belong entirely to the vast, communicating architecture of the cosmos. In the rigorous, unforgiving architecture of the scientific method, a single perspective is never enough to establish an absolute truth. A lone voice in the dark, even if it is the highly sensitive, perfectly calibrated microphone of an advanced robotic rover, is still just a single data point, vulnerable to the isolated quirks of its own immediate environment. To truly elevate a localized anomaly into a sweeping, undeniable planetary reality, the universe demands independent verification. It demands that the exact same phenomenon be witnessed from a completely different angle, utilizing a completely different sensory language. We heard the sharp, acoustic crackle of the Martian spark in the freezing, dust-choked air of the surface. But sound is a fragile, physical wave trapped entirely within the bounds of the thin atmosphere. To prove that the red planet was truly alive with electrical tension, we needed to look beyond the realm of physical vibration. We needed to look up into the cold, silent vacuum of orbit and listen for the electromagnetic echoes of the storm. This crucial, undeniable corroboration arrived in February of 2026, captured by a machine operating in the high, freezing orbital layers of the planet. NASA's MAVEN spacecraft was designed to study the highest, most tenuous fringes of the Martian atmosphere, staring down at the boundary where the fading envelope of gases violently interacts with the harsh, relentless solar wind. MAVEN does not possess microphones. It does not listen to the physical grinding of the dust or the howling of the wind. It listens to the invisible, chaotic spectrum of electromagnetism. It monitors the silent, invisible waves of energy that radiate outward from the planet and bleed into the interplanetary void. And it was within this silent, high-altitude surveillance that MAVEN caught the undeniable, ghostly signature of the Martian spark. To understand what MAVEN heard, we must first understand the true, multifaceted nature of a lightning strike. When an electrical discharge violently equalizes the tension in a swirling storm, it does not merely produce a blinding flash of light and a heavy acoustic shockwave of thunder. The sudden, immense acceleration of electrons tears a massive hole through the electromagnetic spectrum. A lightning bolt acts as a colossal, natural radio transmission tower, violently blasting a chaotic burst of low-frequency radio waves outward in every possible direction. On Earth, these radio bursts from global thunderstorms are constantly bouncing around the atmosphere, creating a persistent, crackling background static that can be picked up by any simple radio antenna. But when these specific, low-frequency radio waves are hurled upward, escaping the dense lower atmosphere and entering the highly charged, plasma-rich environment of the upper ionosphere, something profoundly beautiful happens to the signal. As the burst of radio energy travels through this layer of charged particles, the physical properties of the plasma act upon the wave, slowing down the lower frequencies while allowing the higher frequencies to travel slightly faster. By the time this radio signal reaches the freezing vacuum of space where a satellite is waiting, the original, instantaneous snap of the lightning bolt has been stretched out and distorted. The higher frequencies arrive first, immediately followed by the lower, lagging frequencies. If you were to translate this specific electromagnetic signal into audio that a human ear could perceive, it sounds exactly like a descending, sweeping whistle. It is a haunting, falling tone dropping smoothly from a high pitch to a low pitch in a fraction of a second. In the realm of plasma physics, this phenomenon is universally known as a Whistler wave. A Whistler wave cannot be faked by orbital mechanics. It cannot be generated by the slow thermal expansion of rocks, and it cannot be produced by the steady, unyielding radiation of the sun. It is the absolute, unmistakable, and exclusive electromagnetic fingerprint of a sudden, violent electrical discharge. It is the radio ghost of lightning. When the scientists analyzed the orbital data from February of 2026, they found these exact, descending, low-frequency Whistler waves bursting upward from the Martian atmosphere, perfectly coinciding with the massive, swirling dust storms raging on the surface below. However, the detection of these Whistler waves presented the scientific community with a deeply perplexing, seemingly impossible geometric problem. Whistler waves do not simply float randomly into space. Because they are highly charged electromagnetic signals, they are physically bound by magnetic fields. On Earth, our massive, churning core of molten iron generates a colossal, global magnetic shield that wraps entirely around the planet. When a Whistler wave is born in an earthly storm, it grabs onto these vast, global magnetic field lines and rides them seamlessly out into space, acting like a train guided perfectly by an invisible track. But Mars is a dead dynamo. Its internal core cooled and ceased its massive, churning convection billions of years ago. The planet completely lost its global magnetic shield, leaving its atmosphere totally exposed to the devastating, stripping power of the solar wind. Without a global, unified magnetic field to act as a highway, the low-frequency radio signals generated by the static sparks in the dust storms should have been scattered, completely absorbed, or violently torn apart by the chaotic ionosphere before they ever reached the orbital altitude of Maven. By all conventional logic, the spacecraft should have never been able to hear the whistle. The answer to this impossible paradox lies in the ancient, frozen bedrock of the planet itself. While Mars lacks a unified global shield, it is not entirely magnetically dead. Billions of years ago, when the planet was still young and its core was fiercely churning, magma flowed across the surface and slowly cooled into solid rock. As this ancient rock hardened, the magnetic minerals within it permanently aligned themselves with the powerful magnetic field that existed at that exact moment in deep time. When the global dynamo eventually died and the planetary shield collapsed, these deeply embedded magnetic signatures remained trapped in the crust. Today, the surface of Mars is dotted with these localized, invisible magnetic umbrellas. They are known as crustal magnetic fields, highly concentrated, fragmented bubbles of magnetism that arch out of the rust-colored dirt and reach high into the upper atmosphere. They are the frozen, enduring fossils of a dead magnetic era. During the chaotic violence of the regional dust storms, when the abrasive, relentless friction of the swirling dirt generates a sudden spark of lightning, the resulting burst of radio energy violently expands outward. If that spark happens to occur directly beneath one of these ancient, invisible magnetic umbrellas, the universe perfectly aligns its invisible architecture. The Whistler wave grabs onto the localized crustal magnetic field line. It uses this ancient, frozen memory of a dead core as a temporary, vertical highway, riding the localized tendril of magnetism straight up through the chaotic plasma of the upper atmosphere and bursting directly into the path of the waiting spacecraft. Maven captured the signal because the planet used its own deeply buried history to guide the message into the dark. When we step back and contemplate this sprawling, invisible chain of events, we are forced to confront the deepest, most profound philosophical truths about the nature of the universe and the fundamental flow of information. We walk through our lives heavily biased by our physical senses. We believe that reality is defined entirely by the things we can touch, the objects we can see, and the acoustic vibrations our ears can process. We view the cosmos as a collection of isolated, separate entities. We look out at the void and believe a storm is just a storm, a rock is just a rock, and a radio wave is just a fleeting burst of energy. But the journey of the Martian Whistler wave entirely shatters this illusion of separation, revealing a universe that is completely, inextricably interwoven at every conceivable layer. Information is not a static object. It is a relentless, transforming entity that absolutely refuses to be contained. The fact that a violent collision of dust occurred in a freezing crater is a piece of cosmic data. That data translated itself into mechanical friction, which translated itself into an electrical spark, which manifested as an acoustic pop on the ground, and simultaneously exploded into a broadband electromagnetic burst. That information then interacted with the magnetic ghosts of ancient cooled magma, using billions of years old crustal fields as a physical conduit to reach the freezing vacuum of space, where it was finally translated by a human machine into a descending whistle. The universe is a vast, boundless ocean of translation. Every physical law, every magnetic anomaly, and every swirling grain of dust acts as a node in an infinite, interconnected network of cosmic communication. Reality is a single, unbroken chain of causality, where the ancient past actively guides the energy of the present. Allow yourself to surrender the exhausting illusion of your own isolation. You are not a solitary observer standing outside the mechanics of the world. The same fundamental laws of translation that guided the invisible radio wave across the alien sky are actively processing the information within your own consciousness. Your thoughts, your memories, and the very electrical impulses of your beating heart are all part of this vast, unbroken cosmic transmission. Trust that no action is ever lost, no energy is ever truly destroyed, and that we belong deeply to a universe that is ceaselessly whispering its secrets across the dimensions of space and time. When we picture the raw, unbridled power of an electrical storm, our minds are inextricably bound to the theatrical violence of our own home planet. We imagine the heavy, jagged tear of a blinding white bolt splitting the dark sky, a localized apocalypse of energy that shatters ancient trees and shakes the very bedrock of the earth. We are conditioned to view lightning as a massive, singular event, a colossal hammer striking the ground with deafening fury. Because of this deeply ingrained planetary bias, when we finally captured the elusive acoustic crackle of an electrical discharge on Mars, It was incredibly tempting to imagine the red, swirling dust storms being illuminated by those same massive, sky-splitting bolts of energy. But the universe is a master of adaptation, and the physical reality of the Martian storm is fundamentally different, far less cinematic, and ultimately much more insidious. The lightning of Mars is not a theatrical display of raw, explosive power. It is a subtle, pervasive, and omnipresent creeping static. The secret to this dramatic shift in behavior lies in the delicate physics of atmospheric pressure. On Earth, our thick, dense atmosphere acts as a magnificent, heavy insulator. It stubbornly resists the flow of electricity, forcing the swirling clouds to build up a massive, almost incomprehensible reservoir of electrical tension before the air finally breaks and allows the current to violently flow. It requires millions of volts to force a path through the dense earthly sky, which is exactly why the resulting strike is so overwhelmingly powerful. But the atmosphere of Mars is a thin, freezing, fragile veil. Because the air is so incredibly tenuous, it provides very little resistance to the buildup of static electricity. The electrical tension in a Martian dust devil never has the opportunity to accumulate into a massive, city-killing charge. Instead, the insulating air simply fails early and often. The swirling, abrasive dust generates a continuous, low-energy fizzle. It is a planet-wide phenomenon of microscopic violence, an endless, rippling web of tiny static sparks, similar to the faint, crackling glow you might see when pulling apart synthetic fabrics in a dark, dry room. There are no massive bolts striking the rusty planes, only billions upon billions of tiny, invisible electrical snaps dancing continuously across the shifting dunes. However, we must never mistake a lack of theatrical power for a lack of profound consequence. While a single tiny static spark might seem utterly harmless, the sheer relentless mathematical volume of these discharges fundamentally alters the very nature of the planet. For generations, planetary scientists studying the surface of Mars have wrestled with a deeply unsettling chemical mystery. When our early, uncrewed landers first scooped up the rusted red dirt and baked it in their onboard laboratories, the results were entirely baffling. The Martian soil was not just dead rock, it was highly reactive. It was heavily laced with an incredibly aggressive class of chemicals known as oxidants. The surface of Mars is effectively blanketed in hydrogen peroxide and powerful perchlorates. These are the exact same harsh, caustic compounds we manufacture on Earth to act as industrial bleaches, rocket propellants, and heavy-duty disinfectants. The profound mystery was attempting to understand how a seemingly dead, dormant, and freezing world could possibly produce and maintain such a massive, unnatural abundance of these highly reactive chemicals. Oxidants are fundamentally unstable. They possess a violent, burning desire to react with their environment, to break down and steal electrons from everything they touch. In a dormant world, these aggressive compounds should have reacted with the rocks and vanished into the atmosphere billions of years ago. Their overwhelming, persistent presence deep within the dirt meant that some unseen, relentless planetary engine was actively, continuously manufacturing them right now. For a long time, the only available explanation was the punishing, unfiltered ultraviolet radiation pouring down from the sun, but the mathematics of sunlight could never fully account for the sheer depth and overwhelming volume of the oxidants hidden beneath the soil. The discovery of the omnipresent, crackling static inside the dust storms finally provided the missing, terrifying piece of the chemical puzzle. The billions of tiny sparks dancing through the daily dust devils are not merely an acoustic anomaly, they are the active, driving gears of a planetary-scale chemical factory. Every single time a microscopic static spark snaps through the thin Martian air, it releases just enough localized energy to physically shatter the surrounding molecules. The spark violently fractures the atmospheric carbon dioxide, tearing the carbon away from the oxygen. It rips apart the trace amounts of water vapor drifting in the freezing wind, separating the delicate bonds of hydrogen and oxygen. In the microsecond after the spark fades, these shattered, highly energized atomic fragments frantically crash back together in the swirling dust. Forced by the chaotic energy of the static discharge, they recombine into entirely unnatural, aggressive configurations. The continuous, crackling lightning is actively forging the hydrogen peroxide and the perchlorates directly out of the thin air. As the massive global dust storms rage across the continents, they serve as the perfect delivery mechanism for this newly forged poison. The towering vortices lift the abrasive dirt into the crackling, electrified sky, coat the particles in a fresh layer of highly reactive bleach, and then scatter them across the entire globe as the winds inevitably die down. The entire planet is locked in a continuous dry cleaning cycle, a slow-motion, electrostatic forge that relentlessly churns out corrosive compounds and buries them deep into the rust-colored regolith. The realization of this electrostatic chemical engine carries a profoundly dark and devastating implication for one of humanity's greatest ambitions, the search for ancient extraterrestrial biology. We send our brilliant, sophisticated rovers to the most promising, ancient river deltas of Mars, desperately hunting for the complex, carbon-based organic molecules that would serve as the undeniable fossilized proof that life once flourished in the early oceans of the Red Planet. But biology is incredibly fragile. Organic molecules are the beautiful, delicate, intricate origami of the universe, requiring a gentle, stable environment to survive the crushing weight of deep time. The omnipresent oxidants raining down from the electrified Martian storms are the absolute antithesis of biological preservation. They are a chemical fire that indiscriminately burns through the delicate architecture of carbon. If a microscopic organism died in the Martian mud billions of years ago, leaving behind a complex chain of amino acids or a fragile lipid membrane, those precious biological remnants have been subjected to an eternity of chemical torture. As the toxic, electrified dust slowly settles over the ancient lakebeds, the oxidants seep into the rock. They aggressively attack the carbon bonds, stripping away the electrons, tearing the organic origami to pieces, and breaking the complex molecules down into simple, meaningless puffs of carbon dioxide gas. This is the agonizing, macabre reality of the Martian spark. The very phenomenon that proves the planet's atmosphere is still dynamic and active is the exact same mechanism that makes the surface utterly, completely sterile. The red planet is actively engaged in a relentless process of self-sterilization. The soil is hostile, toxic, and fundamentally incompatible with the preservation of biological memory. Our lonely, mechanical explorers are wandering across a vast, freezing crime scene, desperately searching for the ancient fingerprints of life, while the planet itself utilizes the continuous, crackling lightning of its own storms to scrub the surface completely clean. When we stare into the desolate, heavily bleached reality of the Martian surface, we are forced to confront the deepest, most terrifying philosophical truths about the nature of the universe and the fundamental fragility of information. We walk through our brief lives with a desperate, deeply ingrained belief that the universe is a vast, objective archive. We believe that everything that happens leaves a permanent mark, that history is written in stone, and that the cosmos inherently values the preservation of complex data. We think of information as something solid and immortal, assuming that if we simply build better machines and dig deep enough into the dirt, the ancient truths of the universe will inevitably be revealed to us. But the active, sterilizing chemistry of the Martian storms shatters this comforting illusion. The cosmos is not a museum, and it does not inherently prioritize the preservation of memory. The universe is a churning, chaotic engine of thermodynamics, entirely indifferent to the beautifully complex narratives we wish to uncover. Information requires a physical medium to exist, and that medium is always subject to the violent, erasing forces of entropy and chemical equilibrium. The crackling static of Mars reveals a universe that is just as capable of being an active, aggressive eraser as it is a creator. Reality is constantly overwriting itself in the dark. Entire chapters of planetary history, potentially containing the profound, intricate beginnings of alien biology, are being continuously, silently obliterated by the simple, mindless friction of swirling dust and the resulting snap of a static spark. The universe is under no obligation to keep a perfect record of its own past. To exist as a complex, biological entity capable of holding memories is an act of profound, momentary defiance against a cosmos that naturally defaults to erasure. We are fleeting patterns of data, reading a book whose pages are constantly burning. A humbling reminder that the meaning we find in the universe is precious, delicate, and entirely dependent on the fleeting moments before the cosmic static inevitably wipes the slate clean. We imagine space travel as a magnificent, triumphant battle against the grand, sweeping forces of the cosmos. We condition ourselves to fear the crushing gravity of unseen black holes, the blinding lethal radiation of dying stars, or the catastrophic world-ending impacts of wandering asteroids. We romanticize our exploration as a clash of titans, man versus the infinite. But planetary exploration is rarely defeated by the spectacular. It is almost always brought to its knees by the mundane, the microscopic, and the relentlessly persistent. The crackling, electrostatic engine of the Martian atmosphere does not merely forge aggressive chemical oxidants in the dark. It fundamentally alters the physical behavior of the very ground itself. The millions of tiny, invisible sparks dancing through the howling winds physically transform the pulverized rock, the oxidized iron, and the shattered basalt into a highly charged, dangerously adhesive substance. The dust of Mars is not like the dry, loose sand of an earthly desert that easily slips through your open fingers or blows cleanly away in a gentle, passing breeze. Because of the constant, unyielding triboelectric charging within the storms, the Martian dirt becomes incredibly, stubbornly clingy. It behaves exactly like billions of microscopic, desperate magnets, aggressively seeking out and binding with an unbreakable grip to any foreign surface it encounters. For our current, lonely generation of mechanical explorers, this highly charged, clingy dust is not just a frustrating nuisance, it is an omnipresent, lethal threat that constantly hunts them in the dark. Our uncrewed rovers and landers are magnificent, towering feats of human engineering, built to withstand freezing temperatures, heavy radiation, and the brutal shock of atmospheric entry, but they are entirely dependent on their ability to interact with the environment to survive. When a robotic probe extends a polished camera lens, rotates a complex mechanical joint, or opens a delicate, pressurized valve, the electrically charged dust is immediately and violently drawn to the exposed metal, glass, and synthetic rubber. It coats the intricate moving parts, working its relentless way into the sealed bearings and grinding like liquid sandpaper against the heavily engineered gears. But the most devastating vulnerability, the true Achilles heel of our planetary ambitions, lies in the very source of life for many of these isolated machines, their flat, delicate solar panels. We were forced to witness the tragic, agonizing culmination of this electrostatic threat in the cold winter of 2022 with the slow, public demise of NASA's InSight lander. InSight was a brilliant, highly sensitive geophysics laboratory designed to sit perfectly still on the desolate, flat plains of the Elysium Planitia and listen to the deep, rumbling seismic heartbeats of the alien world. Unlike the massive, nuclear-powered rovers that crawl across the craters, InSight relied entirely on a pair of massive, circular solar arrays, spreading out like fragile, dark metallic petals to drink in the distant, faded light of the sun. But as the silent months turned into years, the electrified Martian winds began their relentless, invisible assault. The highly charged, microscopic dust did not simply settle on the dark blue panels. It aggressively gripped them. It clung to the fragile photovoltaic cells with an electrostatic tenacity that entirely defied the heavy, passing winds. The engineers and scientists back on Earth tried desperately to save their distant, dying machine. They initiated brilliant, improvised maneuvers, commanding the lander to use its robotic arm to scoop up and sprinkle coarse, heavy grains of sand over the panels, hoping the physical, violent impact of the larger pebbles would shatter the invisible electrostatic bonds and carry the fine, suffocating dust away in the wind. But it was a futile, heartbreaking battle against a mathematically superior force. The charged dust continued to accumulate, layer by microscopic layer, slowly and inevitably suffocating the machine in the dark. The vital power output steadily dropped. The internal heaters began to fail in the freezing, 100-degree below zero nights, and the incredible scientific instruments were forcibly shut down one by one in a desperate, final bid to preserve the fading battery. Eventually, the electrostatic grip of the dust completely blotted out the sun, and the InSight lander quietly slipped into a permanent, freezing coma, becoming just another silent, metallic monument entirely swallowed by the clingy, electrified dark. This silent, tragic demise of a stationary machine serves as a chilling, profound prologue for the monumental life-or-death challenges that await us. Within the next decade, humanity intends to take the ultimate, audacious step across the freezing void, sending fragile, breathing astronauts to walk upon the rusted, ancient plains of the Red Planet. When we imagine this historic, unprecedented endeavor, we naturally worry about the immense psychological toll of deep space isolation, the terrifying, fiery descent through a thin atmosphere, and the lethal, invisible bombardment of cosmic radiation. We often picture the dramatic, cinematic danger of an astronaut being violently struck down by a massive, twisting bolt of lightning in the midst of a towering, howling dust storm. But the physical reality of the Martian spark dictates a very different, far more insidious kind of war. The lightning on Mars is too dispersed, too physically weak to violently electrocute a human being heavily insulated inside a pressurized suit. The true, immediate danger to the fragile astronauts will not come from a single, catastrophic strike from the heavens. It will come from the relentless, crawling, electrostatic cling of the dirt at their very feet. Every single time a human astronaut steps out of the protective, sterile shell of their habitat and walks across the charging, swirling sands, their heavy, pressurized suit will instantly become a massive, walking magnet for the electrified dust. The microscopic, jagged, heavily oxidized particles will fiercely bind to the Kevlar and Mylar fabrics, completely coating the reflective visors and deeply packing themselves into the intricate locking mechanisms of the life-saving airlock doors. The true terror lies in the fundamental, unforgiving fragility of biological life support. We require perfectly sealed environments, immaculate air filtration systems, and flawless, uninterrupted electrical connections to keep our human hearts beating in a deadly vacuum. If this highly abrasive, electrostatically charged dust is accidentally tracked inside the habitat, it will float in the artificial, low-gravity atmosphere, clinging to the wet tissue of the crew's lungs, shorting out the delicate, exposed circuit boards of the environmental control systems, and chemically degrading the very synthetic seals that hold the pressurized oxygen inside the module. The frequent, continuous static discharges present a massive, unyielding engineering nightmare, threatening to slowly, invisibly dismantle the intricate, complex machinery that keeps human beings alive millions of miles away from the safety of home. When we look at the shattered, frozen remains of our robotic explorers, slowly being buried under heavy layers of clinging, static dust, and when we contemplate the immense, suffocating challenges facing our future astronauts, we are forced to confront the deepest, most humbling philosophical truths about the nature of the universe and the fundamental concept of information. We are a species entirely obsessed with the creation and preservation of order. We build our brilliant machines, we write our complex codes, and we construct our heavily pressurized habitats as desperate, beautiful attempts to carve out a tiny, structured sanctuary within the massive, sprawling chaos of the cosmos. We view our exploration as a noble, inevitable crusade to push the boundaries of knowledge, believing that our localized information, our fragile biology, our advanced technology, and our very conscious presence has an inherent, unquestionable right to exist and endure. But the electrostatic dust of Mars reveals a universe that is completely terrifyingly indifferent to our localized pockets of order. The cosmos is driven by an unyielding, fundamental law of entropy, an inexorable mathematical pull toward a state of total equilibrium where all complex, beautiful structures are eventually ground down, scattered, and entirely erased. The clingy, abrasive dirt is not acting with malice. It is simply fulfilling the absolute destiny of matter. It is the great, mindless equalizer of reality. Information, whether it is the complex, replicating biological code of a human lung or the highly structured, delicate silicon pathways of a solar panel, requires immense, continuous energy to maintain its shape. The universe constantly seeks to dismantle that specific information, utilizing the relentless, grinding friction of the wind and the subtle, invisible pull of a static charge to slowly overwrite our existence with its own dead, silent equilibrium. To survive in the cosmos, to establish a physical, breathing foothold on an alien world, is to engage in an endless, exhausting, and ultimately unwinnable war against the erasing power of the void. We are not meant to easily conquer the stars. We are fleeting, beautiful anomalies of organized data, forcing our way into environments that are perfectly engineered by the laws of physics to break us down. Yet, the true, enduring majesty of human exploration is not found in the arrogant assumption of our own inevitable victory over the cosmos, but in the profound, tragic beauty of our stubborn, relentless resistance. We know that the dust will eventually win. We know that the universe will ultimately dismantle everything we build, but we still choose to cross the freezing vacuum. We still choose to step out into the howling, electrified storms, and we still fight desperately to leave our intricate, temporary mark upon the unyielding dark. We stand as conscious, defiant sparks of order in an ocean of entropy, proving that the act of reaching into the unknown is a monumental triumph of existence in itself. Good night, and I will see you in the next video.